This is a zirconia mortar and pestle, a solid yttria-stabilized zirconium oxide, the laboratory grinding tool that handles samples too hard for agate and too sensitive for porcelain. Engineered for one job, that is reducing the sample without changing what is in it. Let's look at why labs choose it. The composition is approximately 94.9% zirconia stabilized with 5.1% yttrium oxide. Yttria locks the tetragonal phase, giving the ceramic its fracture toughness, the property that prevents catastrophic shattering during impact grinding. Specific density runs above 6.0 grams per cubic centimeter, modulus of elasticity reaches 200 gigapascals, and crushing load exceeds 15 kilotons. Two properties define the lab tool. Mohs hardness sits between 8.5 and 9, well above porcelain at 6 to 7 and even above agate at 7. Vickers hardness exceeds 10 gigapascals. The mortar surface is harder than the samples passing through it, so the surface stays intact and the sample stays uncontaminated. Chemical inertness covers acids, alkalis, and most organic solvents. In pharmaceutical sample preparation, three things must hold true. The mortar must not contribute particles to the sample. It must not react with acidic API salts, alkaline excipients, or organic solvents. And it must reduce the sample to uniform particle size without losing material. Zirconia delivers all three. Wear loss stays below 0.01 grams per kilogram of grinding cycle. Chemical inertness covers the full range of pharmaceutical media outside hydrofluoric and hot concentrated sulfuric acid. And density above 6.0 grams per cubic centimeter means each pestle stroke delivers strong, uniform impact for tablet trituration and API grinding. The same properties carry across to material science sample preparation, catalyst research, geological mineral analysis, and forensic chemistry anywhere the analyst needs hard-on-hard grinding without contamination. Ultra-pure organic, nanomaterial, and forensic applications as primary use cases for exactly this reason.